Hi guys, we're going to talk about absolute value functions today. I want you to be able to graph an absolute value function and describe any transformations of the parent absolute value function. Okay, what do I mean by parent function? Well, the parent function of any function, remember, is its simplest form. So right here, the parent function is just simply y equals the absolute value of x. No numbers, nothing added or subtracted, just absolute value of x. Now, absolute value symbols are not parentheses. They are these lines that go straight up and down. And your calculator can make those lines to get absolute value. Let's say you want to put a function in your calculator, you hit your y equals. There's a couple different ways to get it. Second and catalog, which is under the 0, and absolute value is the very first item in the list. And you see it makes the double bars with a space to type in between. The other way you can get it, I believe, is in the math menu. It's in here somewhere. Oh, it's under number. But I would say the fastest thing to do is still the catalog, just by virtue of the fact that AB is really early in alphabetical order and it happens to be the first thing. So there's a couple different ways to get to it, but it's easier, faster to get to it from the catalog. And then you would just type anything that you need to type. It'll stay inside the bars until you arrow out. So if you wanted an x plus 3 in the bar, and then you needed to put a -2 on the outside, you just have to arrow out of the bars for your -2. Okay, and I just made that up. I'm getting a little bit ahead of myself here. Okay, so I just put a screenshot of the fact that it's the first thing in the catalog and it makes the bar. Okay. This particular graph, we're going to just review some of our vocabulary here. This particular graph has a minimum. Well, let's use a color. It has a vertex down here. It is a minimum. Okay. I kind of copied and pasted for something I'm going to use earlier or later in the lesson, so I'm not going to use that line right now. I would say that these graphs are V-shaped. Okay. They have kind of some of the same properties as parabolas in that sense. They open up or open down. They have a y-intercept, but also sometimes x-intercept, sometimes one x-intercept, sometimes two, sometimes none. But we'll talk about all that. All right, the y-intercept here is at 0, 0. Okay, and the x-intercept is also at 0, 0 because that's where the vertex is. Domain and range. Just a reminder that domain means what are the x values? What x values can I put? I can put any x value in between these bars. Okay, so all real x. The range, well, for the y-axis, here's my graph. I don't have any points below my vertex. All of my graph is from the vertex up. So for the range, for my y values, it's all y greater than or equal to 0. Now, just a reminder of how I made this graph. Okay, I mean, obviously I pulled a screenshot off the calculator. However, when you guys make this graph, and you draw on paper like you're going to for homework, you're going to look at the table and you're going to pull values off the table to graph. Okay, we'll do a couple homework examples. All right, let's talk about a translation of the absolute value. Okay, so if our parent function, this is what we just did on the previous page. All of these are going to be the same. It has a minimum, okay, a minimum, y-intercept is at 0, 0, okay. Now, what did adding 2 on the outside of the bars do? Well, it shifted the graph up 2. So the graph is up 2. So if I add something to the absolute value, then that shifts it up. So the y-intercept is now at 0, 2, and I no longer have any x-intercepts. The domain is still all real x, but the range now is, it's related to that vertex. So I only have graph values from 2 up. So y is greater than or equal to positive 2. Okay, so that's a change from the parent function, which did have an x-intercept right there at the vertex. Domain stays the same, all real x. And the range here was y greater than or equal to 0. So you can see that the vertex and the range are related. All right, if we put a -3 at the end of the graph, what did that do? Well, it brought the whole graph down 3 units. So the graph is down 3. Now the y-intercept is at 0, -3. The x-intercept, it has x-intercepts, they're right here. Okay, the x-intercepts are at -3, 0 and +3, 0. Domain's still all real x. Now this time the range is y greater than or equal to that lowest point, -3. All my y values are above -3. All right, if I add or subtract a number inside the bars, in other words, I'm just adding or subtracting a number to just the x. Guys, if you remember doing transformations before, if you add and subtract like we did on the previous page, add and subtract something to the whole function, it moves the function up or down. If you add or subtract something to just the x, it moves it side to side, okay? But in the opposite direction in which you think. Okay, so I'm not going to fill in all this stuff again over and over again for y equals absolute value of x. Okay, because that's going to be the same every time. Here, you're going to notice that once I put a +2 on the inside, it shifted the graph left 2. Now, plus kind of common sense makes you think it's going to the right, but remember x always behaves in the opposite of what you think, so it's going to the left 2. The y-intercept is now up here at 0, 2. The x-intercept is at -2, 0. It's also the vertex. The domain, still all real x. The range is y greater than or equal to 0. Look where your vertex is. It's opening up. The lowest y value is 0, so it's y greater than 0. If I subtract 3 on the inside, the graph moves to the right 3. The y-intercept now is at 0, 3. The x-intercept is at 3, 0. Domain, all real x. Range, here's my lowest y value. My lowest point on the graph is here. Okay, it's at the same, that vertex and the x-intercept happen to be the same. Okay, that lowest y value is 0, so it's going to be y values greater than or equal to 0. Well, I found a typo. Negative. There we go. All right, negative outside the absolute value. So here's what I'm talking about. Okay, there's a negative outside. Well, what did that do? A negative on the absolute value flipped or reflected the absolute value of x. I just flipped it over so it opens down, just the same way that in a parabola or a quadratic, a negative leading coefficient of a will make the parabola open down. Okay, same thing with absolute value. So this one has a maximum. In fact, because there's a negative sign for all of these, they all have maxes. Okay, so the graph is reflected over x-axis. Y-intercept stayed the same, it's still 0, 0. X-intercept is still 0, 0. Guys, I would also tell you that there's no reason to try to do the intercepts in your head with these, especially when we do multi transformations. Just look at it on the graph and find the intercepts that way. Don't try to do them in your head. Domain, all real x. They're all real x. Okay. The range. Okay, so now that this function is opening down, the y values are all going down. They're less than. So y is going to be less than or equal to 0 for the range. Okay. For the middle graph, it says graph is, we're going to have to squish this in here. Okay. Reflect. I'm going to abbreviate over x-axis. And we added another element. We have -3 inside the absolute value. Think, what does that mean? Right, left, up, down. Inside. Okay, hopefully in your head you said it's to the right 3. Okay, so we took our original V-shape function, we flipped it over so that it opens down, and we moved it 3 to the right. The y-intercept is now at 0, -3. The x-intercept is at 3, 0. Range, well, this is my highest y value right here at the vertex. So all y values are less than or equal to 0. Lastly, we now have a +2 in addition to our negative. So reflect x-axis, and the +2 is on the outside, so I went up 2. The y-intercept is right here. I can see it at 0, 2. Our x-intercepts are at -2, 0 and +2, 0. Range, that goes back to the vertex. The highest y value is 2, and all other y values are going to be less than 2. So y is less than or equal to positive 2. Okay, lastly, we're going to do our dilations of the function, where each function is, we have our parent function in the beginning. Okay, now we're given a coefficient out in front. Okay, so what does a 4 do? What does a half do? Okay, so dilation, coefficient, in front of absolute value. You know what? That's a bit much. Let's just take that out. So we're putting some sort of number in front of the absolute value. Okay. So you can see the graph. If I put a 4 out in front, it made the V skinnier. It still has a minimum. Okay. Graph is narrower. The y-intercept is still 0, 0. It doesn't affect that. All it does is affect how wide the V opens up. Domain, still all real x. Range, here's my vertex. Y greater than or equal to 0. Now, if I put a number, so 4 is a number that's greater than 1. 4 is greater than 1, so that makes it narrow. If I put a number like a half out in front, where a half is less than 1, it makes it wider. So anything that's a fraction, or it could be a decimal of 0 point something. Okay, I don't want to get into negatives because that's what we just talked about. A negative is not only going to change how wide or narrow the V is, it's also going to flip it over, which is a separate thing that we just talked about. Okay, so I really just want to focus on the coefficients right now. So this still has a minimum. Graph is wider. Y-intercept stays the same. X-intercept stays the same. Really, guys, I'm including all this intercept stuff just because, especially domain and range, I'm including in this lesson because it's a vocabulary refresh that we're definitely going to be needing as we approach the regents, because you're going to get asked domain and range questions. All real x. Range, here's my lowest y value. Here at 0, 0, all the y values go up from there. Y greater than or equal to 0. Okay, so on your homework, here's what I want you to do. In your calculator, where are you? There you are. I want you to keep the parent function in your y1. So second catalog, x, nope. Absolute value, x. I got one button push ahead of myself. Okay, keep that in your y1. Then each homework problem put in your y2. So we're going to go second catalog, absolute value, x, take away 2, arrow out, and minus 4. Okay. What I want you to do is go to your table, graph the y2. In other words, only graph the function that you are given here. Okay, so I'm going to follow the, let me pull this out. I'm going to graph just the y values in red for y2. So -6 and 4, -5 and 3, -4 and 2. Okay, you have to be careful to look for where that's going to turn around. It might not. -3 and 1, -2 and 0, 0, -2, 1, 3, 2, 3. Okay, so I can see that this is what the graph is doing so far. Okay, here's the vertex. Here's where it changed direction. We can solidly say it's going to keep following this pattern, going in this direction. Arrows on both ends. Label your graph. Okay, now in the space over here in between, I want you to talk about what the -2 and the -4 did to your parent function. So the -2 is inside the absolute value symbol, so it moved right 2. The -4 is outside, that means down 4. But here's why I want you to put it on the calculator. You can look at the graph, and basically whoops, I didn't mean to do that. Let's pull that out. On the graph, you can follow it. You can count it out. Make sure you turn your grid on, and you can say, okay, here was the old vertex. Here's the new vertex. What happened? 1, 2, 1, 2, 3, 4. Okay, so you can see it right on the graph. Let me move these out of the way. I also want you to, I'm not going to have you do the domain because that's all real X all the time, but I do want you to do the range. And again, we're just going to do the range of the homework question, not the range of the parent function. So the range of this function, here's my vertex. My vertex is at a y value of -4, and all of my graph is above the -4. So my y value is greater than or equal to -4. So this is extra that's not in the directions on your homework. I just want to reinforce those things as transformations of functions in general on your homework. I want you to practice those things. Okay? So let's do one more. So we have y equals absolute value of x plus 1. So in our calculator, again, we're going to leave the parent function in there. I'll change this to a plus, change that to a 1, delete out the -4, and pull out my table. I don't need -7, so I'm going to arrow out of that. Okay, so graphing. Remember, I'm just graphing those y values against the x's. So -5 and 4, -4 and 3, -3 and 2, 1. Don't forget to label. Okay. So again, I wanted you to talk about not just making the graphs, but I want you to talk about what shifted from the parent function. And you can just look at the graph on your calculator. All right, so what does adding 1 on the inside do? It moved our vertex from right here at the origin. +1 moved it to the left 1. So it moved our function left 1. Didn't move up, didn't move down, didn't change how wide it opened. Okay, just moved it to the left 1. Okay, and the range did not change. Okay, it's still, the lowest y value is 0, and all of our y values are greater than or equal to 0. And you can see this in the table too. You can see what the range is doing. So if I look at the table, all of the y values, here's 0. All the y values above it are going up, and all the y values underneath it, 1, 2, 3, 4, 5, 6, those are all increasing. So even if I arrow through the table and look at different parts, I'm never going to get a negative value there. So all of my values are 0 or greater. So just to reiterate, I want to make sure I tell you, and we add the directions right here on the homework. So our additional directions are to describe the transformation from y equals absolute value of x. How is it different? Okay, did it move up, right, left, down? How many? Did it reflect over the axis because you had a negative out in front? Did it become narrower or wider? Did it do a combination of those things? Describe everything that happened, okay? And secondly, I want you to talk about the range. What is the range of each of your graphs? Okay? Use your table to make your graphs. I want to see dots with things connecting, with lines connecting them. Okay? These are not sketches. We are not just throwing some V's on the page. I want to see dots. I want to see evidence that you used your calculator to help you graph and use your table. Okay? Thanks for watching. Have a good day.